All right, so 5.7 shouldn't take us very long because I've already given you the information on this, and it's just simply a matter of using the information in somewhat of a practical format. So the game is this. We've talked about it. So an arithmetic sequence. Basically, it's linear. Shh, don't tell anyone. So it's linear. That is, you're adding the same amount each time. Okay, and so explicitly, it would look something like this. You'd have an initial value plus the common difference times n minus 1. Okay, that's explicitly. You want to have the 18th term, take the first term, plus add the common difference 17 times to that, because obviously the first term, I'm sorry, this should say T1, sorry. Take the first term and then add the common difference 17 more times. Where does that put you? It puts you at the 18th term. It's not very difficult. Okay. And so there you go. Now, obviously, in explicit and recursive format, of course, you need to tell me what T1 is, and then the nth term is going to be the previous term plus the common difference. Okay, this is, of course, this go hand in hand. Again, it's recursion. And up here, of course, this is explicit. Yeah. So let's do a couple of those maybe. I don't know. So I don't know. There it is. Cool, whatever. So can you find me the 19th term? I don't know. Probably 3 plus. What are we adding? We're adding 4 each time. Okay, does that make sense? Probably. 15, 19, 23, 27, 31, 35, 39, 43, 47, 51, 55, 59, 63, 67, 71, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19th term. That's all there is to it, friend. Okay. And again, I already showed you that, so it makes it kind of an easy deal there. Geometric. There's two kinds of geometrics. There's a finite. It looks like this in the explicit format. It is, your book uses A. I don't care for that. I prefer T1 times R to the n minus 1, where R is what's called the common ratio. In other words, we're adding, or multiplying rather, we're multiplying by the same value each time, which means that if you had 3, then 6, then 12, 12 divided by 6 is the same ratio as 6 divided by 3. Why? Because we're multiplying by 2 each time. Okay. Now, the reason that they write the way they do is because they realize that this, if you write it like this, a to the times r to the x, or x minus 1 or whatever, but this is, what is this? This is exponential growth, right? Exponential. Okay. That's just kind of what we talk about there. Where a isn't necessarily T1, because if you think about this, this is really T1 times r to the n times r to the minus 1. And what is r to the minus 1? Well, it's 1 over r. Oops. And so this right here would be your a. In other words, if you wrote it in this fashion. Okay. So this is a finite geometric sequence. So for instance, 3, sure, 6, 12, dot, dot, dot. And then out here somewhere I get the 17th term, because why not? So that'd be 3 times 2 to the 16th power. 2 to the 16th is a pretty healthy number. I don't know what it is off the top of my head. Actually, I've never known it. Is this disgusting huge number, and 196 and 608. That's not as big as I thought it was. But that would be the 17th term in this list of numbers here. Okay. We also see an infinite geometric series, infinite. And so infinite and finite don't change. I shouldn't say that. Infinite and finite don't change in the systems that we're doing right now, because all we're trying to do is find the this specified number. Now, clearly, if you said to me, Jay, what is the infinite term? I would tell you to go fly a kite. There is no such thing. But in terms of if you want to find a finite number, whether this thing goes to infinity or not, right? Maybe I just let this series just go forever, but I'm only interested in the 17th one. Go find the 17th one, okay? It only matters really in these two if you're finding the sum, which I showed you a couple of videos ago. It matters. If you let it go to infinity, then obviously if you're multiplying by a number bigger than 1, it's not going to converge. If you're multiplying by a number between 0 and 1, it will converge eventually. Cool. All right, so let's do one here. Let's do number 3, I guess. Sure. A sequence is defined recursively. Use iteration to guess the explicit formula for the sequence. Use the formulas from 5.2 to help you simplify your answers when possible. Cool. So here's the recursive property. Actually, I'm number 4. Number 4 is bk is equal to bk minus 1 over 1 plus bk minus 1. And our initial term is 1. I don't care how they use it. They start off with that. It doesn't matter to me. I don't care for it. The 0th term is 1. Cool. Well, let's put in the first term then, shall we? Okay. So if I want the first term, that would be b1. It'd be equal to 1 minus would be the 0th term. So it'd be 1 over 1 plus 1 is 2, so a half. Okay. If I want the second term, take a half. 1 plus a half is 3 halves. When you invert and multiply, you get 3 halves. BQ, 3 halves, so then it'd be, no, wouldn't you, dummy? When you invert and multiply, it would be 2/3, which would be 1/3. 1/3. Try again, dummy. All right, so it's going to be 1/3, and then it's going to be 4/3. It's going to be 1/4. Oops. And so on and so on and so on. Okay. Now, let's think about this for a minute. Now, that's pretty straightforward. That's all fine and dandy. What would our t sub n look like? This one is neither arithmetic, that is, we're adding the same amount, nor is it geometric. It's just a different weird one. That's cool. Well, I feel like this is the first. This is n equal 1, n equal 2, n equal 3, n equal 4. So this sure looks a lot like 1 over n. That's what it looks like to me. And that would be the answer. Okay. Let's do another one of them. So 2 to the k, so h of k is equal to 2 to the k minus h of k minus 1 over, no, that's it. And then it's h naught is, h0 is 1. And k is bigger than or equal to 1. Okay, that's cool. So the first term. Now let's see, when I put it, so then the second term, or so the first term would be equal to, plug this in, you're going to h1 is equal to 2 to the 1th minus the previous term is, well, it's 1. So h2 is going to be equal to 2 squared minus the previous term, which is 3. h3 is going to be 2 to the 3rd minus 3, which is 4. h4 is going to be equal to 2 to the 4 minus 4 rather. Wait, what happened? I forgot my 4. Which is going to be 12. 2 to the 5th, which is 32, minus 12 is going to be equal to 20. Okay. Interesting. There comes a time when I think it's helpful to quit screwing around with it and go use Excel to crunch the numbers. So that's what I am going to do. At some point, it just makes your life so much easier. You're like, well, I could spend a day or two messing around with it. Well, you could, or you could just get Excel out. After all, that's what it's made for, is this kind of thing. And my keyboard doesn't want to work. Why don't you want to work, you hunk of crap? Okay, now you want to work. All right, there you go. So if it's me, this is what I'm going to do. So I'm going to put in the n terms here. So a k, I guess your book uses k. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so forth. And then this is the h of k. And so it was 1. And then this was equals 2 to the 1th minus the previous term, yes? And drag her down. See, this is why I do this, because if I look at this right there, what did J do? Oh, he blew it. I think I had a 12 there, right? Remember that? And I think I had this one wrong too. I think I had that as 20, but then of course that's wrong because that one was wrong. This is why it's stupid not to do it that way, okay? Now, what I'm going to do is this. I'm going to subtract this guy minus the previous guy. It's quite clear I'm not multiplying by the same number each time. Is that clear? Wait, these numbers here, like, what's going on here? Something's a little screwy. Something is a little screwy. Let me pause one moment while I think about this. Don't waste your time. Okay, so there's my list of numbers. Nothing strikes me now. I've tried messing around with it in Excel, so nothing came to me like that. So I thought, well, okay, let's just actually try the math here. So let's do this. So if I take this, my h1 is this minus h0. Then h2 is 2 to the first, or 2 to the second rather, minus this guy. Cool. And h cubed is 2 to the third minus this whole thing. And so on and so on and so on. So let's go ahead and go a couple more here, just see what happens. Okay, let's distribute this out a little bit. This one doesn't change, of course. Like so, yeah? Okay, so what's happening there? All right, well, if you do some math on that, guy, it's I think, fairly clear that what are we multiplying by each time? Okay? I think it's pretty clear that we're multiplying by, each time we do this, we're multiplying by -1. On look at your end one out there. Look at these guys. They change signs. Look at these guys. They change signs, right? So that's going to be a kind of a big deal going forward. Okay? So just be aware that they're going to keep changing signs. So there's going to be somewhere in this mess, there's going to be -1 to the nth power or something of those natures. Okay, so be aware of that at some point. Okay, we're going to have to see that happening. Okay, so when we do the math on that, you can bring all those different pieces to bear on it, but that's going to obviously be happening. What if you were to okay, I won't give you this one hard. I won't give you the one this hard. I promise. But this one I actually had to go look up in the answer key a little bit to give myself a little bit of I got this far, but then after that I was kind of like, So if you factor -1 to the nth out of all those guys, what are you left with? Well, you're left with 1. So you're left with 1 minus, and then just go up the line the other direction. So it's going to be 1 minus 2 plus 2 squared minus plus ... whatever. And then the last one is going to be plus, and it's going to be -1 to the n times 2 to the n. Okay, and the reason for that is, and it's kind of weird, but think about this. This first guy is always positive, yes? So you pull the negative out of it. This negative and this negative just fixes everything. So what's the difference between these guys? This in here, you're multiplying by -2 each time, correct? Does that make sense? We're multiplying by -2 each time across there. And then what is that? Well, that right here, this is a geometric sequence, is it not? Okay, we're timesing by 2 each time, so our R is equal to negative 2. Oh, that's nice. So then what does that happen? Well, it says that my nth term is equal to, right? It's the first term, which was 1, times r, which is negative 2 to the nth power, correct? Okay, I'm sorry, to the n minus 1th power, sorry. N minus 1th power. Like so. That's how ordinarily it would go, okay? Because that's where we started on these deals. But bear in mind that we started with the 0th term, right? So in reality, the 0th term is the 0th term. That formula, this formula that I showed you, this formula right here, over 1 minus r, that formula that I gave you, no, I'm sorry, that's for the sum, you dork. So this guy here is just works for when r from n goes from 1 to wherever, right? So we're not going from n to wherever. We're moving along this case here. Okay, so remember, this is a sum, though, correct? We are doing a sum. And that's what throws people off. We're thinking we want the nth term, but the nth term is a sum of the previous terms, yes? So if you think about this, forget about this guy for right now. The way I wrote it out for you, it looks like this. It's 1 minus, so it's t1, 1 minus r to the n over 1 minus r, okay? That's personally how I like to go about doing it. So that's how I personally have done it for my whole life. Your book sometimes writes it this way, and it is what it is. If that makes you happy, it's going to be the case that if I start off with the sum, and they write theirs this way, the sum where n goes from 0, or I'm sorry, I goes from 1 to n, rather, of just r to the n. They write it thus. Now, why is this the same? Why is that the same? Well, it's exactly the same because they assumed, you see, that your initial value is what? It's 1. Okay? So if the initial value wasn't 1, there'd just be a big T1 right here, right? It's exactly the same process. And the difference, why is it n minus 1 right here? Because we started at 0 compared to mine. Okay? So if you think about that, we're gonna need that information. That's for playing along here. It's not that hard though to think about. So then the question then simply becomes this. So clearly we have our goal here is to take the and again in this series right here, our initial term is 1, so it's 1. Don't have to worry about that. And then it's gonna be 1 minus negative 2 to the n. To the n power for right now. We'll talk more about that. We're going to change that in a second. Over 1 minus a minus 2. Or 1, rather negative, yeah, 1 minus a minus 2. Right, exactly. Okay, there we go. Now, the only difference between what the book has and what I have is they write it a little differently. They write it like this, and let's see if we can figure out why theirs is that way. If you're looking at the back of the book, you're like, I'm following along their answer, Jay, and it's a little different than yours. It is. It looks like this. Okay. And then they have the negative 1 to the n out front, which of course I have as well. I just didn't write there. I'm not stupid. Okay. I'm not totally stupid. Okay. Now, let's see if we can figure out the difference, why that is. Okay. Because we have this term, okay, and we have to include, we have that one more term because of that 0th term there. So that's where they ended up with that on the top one there. Okay. So let's see what we got going on here. All right. If you can clean that up a little bit, all right, what do you notice? Well, it'd be really cool if this was also an n plus 1 right here, yeah? It'd be really cool. Well, what would that mean? Well, I could do it this way. I could go negative 1 to the n plus 1 upstairs, okay? Meaning that I multiplied by negative 1 upstairs. And if I do it on the bottom, I must do it on the top as well, yes? Or vice versa, I guess is what I said. So what ends up happening is you end up with this on the bottom, 3, okay? And then you end up with, if you distribute that, what do you get? Well, you end up with this times this is 2 to the n plus 1, right? And then it's going to be minus. Now, well, hold up now. Let's think about this for a minute. It's negative 1 times negative 1 to the n plus 1, right? And so when you times that out, or we just going to be minusing the 1 times that. Yeah, you could have done it a little differently, I think. Anyways, let's see what happens there. Let's see if this works for us. So if I wanted the, again, I won't give you one that's hard or ugly. This one's kind of gross. Let's do the 1, 2, 3, 4, 5, 6, 7. Let's do this. Well, let's do this. 1, 2, or 0, 1, 2, 3, 4. Let's do the fourth term just for fun, shall we? See if we get this right. So that's 2 to the 5th minus. So the fifth term would be, no, the fourth. Did I say the fifth term or the fourth term? The fourth term, correct. And then 4 plus 1 is 5, so that's going to be negative 1. So we're going to plus 1 over 3. That's 32 plus 1 is 33 over 3 is 11. Done. Works. I'm going to do one that's a little more what I'm going to give you in the test on the homeworks and stuff. I apologize. That's a little gross, but it's not terrible. It's just a little grosser than I plan on giving. If this was a class for math majors, maybe I'd spend a little more time on that. It's just, I think you need to understand the process of recursion and a few things, but beyond that, for most of you, yeah, you're not going to go a whole lot beyond that. So let's do the following here. Let's say that one. Okay, I will say this, that I don't like the way your book jumps all around from S to T to K to P to L to whatever of K. I always use T for the nth term, whatever the T, this whatever term it is. But since they use H frequently, I'm going to stick with H. This problem, they actually use S, which I find obnoxious and offensive. Okay, think about what's happening here. We're taking a value and we're going to add 2 to it. Right off the bat, you're like, oh, this feels arithmetic. You're right. I think it does feel arithmetic, but be careful. So my first term is 3. And then I'm going to add 3 plus 2 times 1, which would be 5. And then I'm going to take the previous term, which is 5, and I'm going to add 2 to the, what here? 2 to the 2 seconds, or 2 times 2 is 4, so 5 plus 4 is 9. Okay, and then you're like, all right, what's next? All right, so then it'd be 9 plus 2 times 3 is 15, I think, and then 15 plus 2 times 4, which is 8, so 23. And let's go a couple more just for fun. 23 plus 10 is 33, and then 33 plus 12 is 45, I think. And just for fun, let's look at that in Excel as well. Just again for a good time, see if we like that. Our 0th term was 3. Okay, and equals that guy plus 2 times this dude. And let's get rid of this. Just for fun, clear contents. And then drag that baby down, double click him down, whatever. Boom. Which I think are all my numbers that I had. Nice. So right off the bat, you're like, oh, this is pretty straightforward, I think. Well, maybe, maybe not. Probably should have just left that here because I was doing subtraction. Let's do subtraction. Something that occurs to me is that I'm 2, 4, 6, 8. Wait, now, aha, let's do the second difference. Equals this guy minus this guy. And clearly we're adding 2 in the second difference. That means this equation is a quadratic equation. If the second difference is constant, it's quadratic. Okay? It's quadratic. So let's see what we got out of this deal here. Okay, now why is that second difference constant? I don't know, let's find out. So you had 3, you're going to have 3 plus 2 times 1. Oops, that's a comma. Then you're going to have 3 plus 2 times 1 plus 2 times 2, comma. And then you're going to have 3 plus 2 times 1 plus 2 times 2. That's the previous term, plus 2 times 3, and so on and so on and so on. Okay? Now look what's going to happen here, friends. When you subtract, what's going to happen? Take this minus this, the 3's cancel off. I take this minus 3, the cancel, this cancel off. Take this minus this, the 3's cancel off. Does that make sense? Okay? But what am I left with? Here I'm left with a 2, clearly, because there's a 2 to the first left over. This minus this, the 2 to the 1's cancel off. You with me? And you're left with a 2 to the 2. And so when you subtract them, you're going to be left with a 4 there. Okay? And then this minus this, those guys cancel off. You're left with a 2 to the third. Cool. And then if you think about it, okay? I'm sorry, 2 to the second. So then this is 4 minus 2 is 2. And this 8 minus 4 is, wait, what just happened there? I screwed something up. When am I subtracting here? Well, whatever. You saw the math when you subtracted, but that's the game. Okay, you can see what we're subtracting off of there. It's pretty easy to do. All right, so on this problem, we need to have n. We need to have some kind of quadratic function of n, right? Well, when n is 0, n equals 0, what's c? Well, that means this guy is 3 pretty clearly, right? That makes sense? So this problem is not too hard to do, because then one guy can just go, all right, that's neat. So what if I did t or h? Let's do h of 1. I know it has to equal a plus b plus 3, right? When you plug 1 squared plus that in. What about h of 2? Well, you plug that in, you get 4a plus 2b plus 3. Now let's subtract them, shall we? 4 minus 3a is 1. Oops, don't subtract yet, dum-dum. Let's times the top equation by 4, shall we? And so now you get 4a minus 4b. 4a minus 4a is 0. 4 minus 2 is 2b. And then plus 9 equals 0. Interesting. So b equals negative 9/2. Looks like that's true. So then you'd have h of 1 again was a minus 9/2 plus 3. And what did that have to equal? That had to equal 3. Oh, yeah, I almost screwed up. Well, I did kind of screw up. Let's back that train up a little bit. I didn't screw up as far as I went. I just kind of screwed up in part of it. Let's try it again. So it's a plus b plus 3. What does h of 1 equal, dummy? 5. What does h of 2 equal? 9. Here we go. Okay, let's try this again, shall we? So I'm going to do this down here. I'm going to go a plus b equals 2. Quite clearly, if you subtract, you get 4a. I'm going to write this on top, plus 2b. And then minus this is equal to 6. Hey, look at that. Jay might do it right this time. So times by 4. All right, now let's try subtracting now, dummy. 4a minus 4a is 0. 4 minus 2 is 2. 8 minus 6 is 2. B is equal to 1. If that's true, then it's pretty clear a is also 1. So you're going to n squared plus n plus 3. Does that work? I don't know. Let's find out, shall we? Let's see if that works. What about the fourth term right here, shall we? So, oh, I'm sorry. That would be the third term. Remember, this is the 0th term, first, second, third term. The third term is going to be 9 plus 3 is 16. What about this term here, which is 4, 5, 6th term? 36 plus 6 plus 3 is 45. Check. Nice. Okay. So those aren't too bad to do, I don't think. So, you know, a classic example of this is if you're saving money in an account, and if you don't put anything else in or take it out or whatever, and then, of course, you all know, you've seen this equation before, you will have that the interest is equal to principal times 1 plus r over n to the nt. That's the interest rate formula for compound interest. You know, n equals 12, then it's monthly. That is 12 times a year. 12 times a year, I give you 1/12 of your interest rate. And so it would look like this if you put 600 in the bank, and you're going to leave it in there for 5 years at compounded monthly at 2% interest. It would look like this. And I said, did I say 2 years? Did I say 5 years? I don't remember. Let's say 5 years. Then it would look like this. And why 60? Because there's 60 months, you see, in 5 years. Now, I am going to use the calculator here to do it. Then I'm just going to show you how I do this in Excel. I do this, I teach a class, I do a ton of financial math in one of the classes that I teach elsewhere. So I've gotten, better at doing this from an actual, literal standpoint. You'd have $663. Me personally, I prefer to put 600 here, and then I actually like to put an interest column over here, but you don't have to. You can hard code it, so I'm just going to hard code it for now. Times 1 plus 0.02 divided by 12 to the, oops, that's it. That's all, sorry. And then notice that this is recursive. The way I'm doing it here, because I'm only referencing the previous cell. This one down here was completely explicit. So I prefer this method actually. Now drag it down to 61 because the 60th line is not the 60th month. The first one was the 0th month. And so there you go, 663.05. Hey, what do you know about that? Again, I like to, if I'm doing this for my own personal stuff or if I'm trying to keep track of what's going on, guy can do this if they wanted to. And then you could just reference this in here. You can go in here and you go, all right, let's do plus this fella. Now, it's important that if you're doing this, then you're going to have to do F4, lock it in, and then divide by, and then you could just go over here and you can do that, and you can divide by that as well. Oops. In the real world, what you're going to notice is that, yeah, we almost exclusively use monthly compounding. But if I change this, everything updates. Okay, but it's the same thing you've done your whole life. That's just an exponential growth formula. That's right. It's also a geometric sequence. That's all you're doing. Pretty fun. Almost a good time. Like one of my favorite examples of this when I was a kid, or not a kid, when I was a younger teacher, we used to do these. We used to do this shake the Skittles box. So we'd take a box and you'd put a Skittle in there, or 2 or 5 or however many Skittles, and you'd shake it around. And if the S landed up, then the Skittle would reproduce. And if it didn't, well, it didn't. Now, the Skittle's 2 sides, basically. So it's basically a 50-50 chance of them having a kid, right? Basically. And then it would grow. And then if it had a kid, you'd add 1 Skittle. And then some populations we had, they were more fertile. So for every time their S showed up, you'd put in 2 more Skittles. Like they always had twins or something, kind of a thing, right? Anyway, funniest story ever, though. This one kid goes, Mr. Groom, there's something wrong. I've shaken this box 10 times, and then S never comes up. I think I have a defective something or whatever. I looked at him like, dude, you've got a eunuch. Your S, there's no S on your Skittle, friend. He was so angry. I'm like, you think you would have checked that out ahead of time, but whatever. Anywho, so when you do this, think about this. So there's 1 Skittle in the box initially before the 0th shake. And after the first shake, let's say it shakes, it lands it with a heads up. What are you going to have? We're going to add 2, right? And the idea here is there's a combination between probability and the growth rate, right? So what should be happening is, in theory, half of the Skittles in the box are going to reproduce, in theory. Or in other words, they're each going to reproduce every other time, basically. And so what should happen on the next one, right? Well, 50% of these should reproduce, yes? And so look. And so for the one that reproduced, you're going to add 1 more, and you're going to get 3. And you just keep going like this. Now there's 3 of them in the box. You shake them. Now, sometimes you're going to add 1, sometimes you're going to add 0, sometimes you're going to add 2, sometimes you're going to add 3. But in general, you would expect to make, well, there's a 1 in 8 chance that I get 0. There's a 1 in, There's a 3 in 8 chance, rather, that I get 1. There's a 3 in 8 chance that I get 2. And then there's a 1 in 8 chance that I get all 3. If you add that all up, that's 3/8 plus 6/8 is 9/8 plus 3 more 8s is 12/8. Look at that. 1.5 is what you'd expect, which is exactly, if I asked you, how many would you expect? Well, 1.5 of them to reproduce. Well, it can't happen. But in theory, that's what you've expected, right? And so this equation came out to be always the initial population. So population at some time n is the initial population times 1 plus 0.5. In this case, because it was just one time a year, in essence, that they reproduced, if you will, to the n minus 1th time. Okay? And it was just a really funny deal because that kid was just beside himself. He could not figure out what he was doing wrong, and that's what it was. So just gonna keep that in mind. It's not too bad. 5, 7, I think you'll find to be fun. I think the ones I assigned aren't terrible. Guess you'll wait and be surprised.